All right, so 12.1, introduction to limits. So limit is the first thing. Congratulations, you're now done with pre-calc. You're now calculus students. Limits is the first thing that you do in calculus class. So next year, those that are taking calculus will maybe do a quick little review, and then the first topic is going to be limits. So limits is kind of the foundation. We'll end up toward the end of this unit learning what a derivative is. So you need a limit in order to find a derivative, and then derivative is the whole first half of calculus. Everything's based off of limits and derivatives. So limits is the first topic in calculus. I'll start by loosely defining what a limit is. It's a y value that a function approaches. So the key word there is approaches. Does not mean that it has to get there, it just has to approach it. So if from the left and from the right, if a function is getting closer and closer to the same y value, then that y value is what the limit is. It's a y value that a function approaches. I'm going to make a list of ways to find limits. So 2 ways to find limits. This isn't in your notes, you might want to write this down. So number one way to find a limit is always going to be direct substitution. An example, if I have, okay, so the way this is read is the limit of x squared minus 1 as x approaches 2. The limit of x squared minus 1 as x approaches 2. So direct substitution means, okay, so what y value does it approach? What y value does this expression approach as x approaches 2? Well, I could just literally just plug in x, or 2 for x, so I get 2 squared minus 1, so 4 minus 1, we get 3. That is the limit. The limit as x approaches 2 is 3 there. It's also middle school math. Plug a 2 into for x and you get your answer. Okay, so direct substitution is not typically how you're going to be able to evaluate limits, because literally all you're doing is plugging in a number. Okay, so it's not that interesting. We'll do other ways. So like, we'll do graphing. So if I looked at the graph of this, what kind of shape is y equals x squared minus 1? What kind of shape is this? Yeah. What is that called? You look like a priest up in front of the, you're about to bless the congregation. A parabola, yes. She was going, am I sideways? She's going like this. Oh! All right, transition back to 2 dimension. Where'd it go? Okay, it caught up. So it's a parabola. It's a parabola that opens up. It's got a y-intercept of 0, or vertex at -1 with 0, -1. So it looks like this. So there's my parabola. And as x approaches 2, there's 1, there's 2. It goes to the value 3 right there. So that parabola keeps going. What is the y value as x approaches 2? It is 3. So from the graph, we can see that x goes to 2. From the left and the right, it goes to the y value 3. Again, not that interesting, because you didn't even need to graph it. You could have plugged 2 in right here. But if you did have a graph, you could literally just look at it and say, oh, at 2, its value is 3. Okay, so things will get a little more interesting, hopefully. What if we had the limit of sine x, which is 0? What is that one? Well, we could try directly substituting it in. If you plug 0 in for the top, what is the sine of 0? There's a throwback question for you. What's the sine of 0? 1. It's either 0 or 1, right? What is it? Everyone agree that it's 1? Sure. Does anyone think it's 0? The only one confident right now is the one grabbing your calculator to figure it out. On the unit circle, look at, on the unit circle, at 0, what's that ordered pair is 1, 0. What's the sign of that point right there? Sign is y value. 0. It is 0. So the sign of 0 is 0. If I plug 0 in for x, I get 0. At least you said something, right?
I was close. It was one or the other.
Yeah, you're right. Flip a coin.
Probability of that is
Yeah, see, you learned something. What is 0 divided by 0? It can be 0.
Or 1.
It could be 1. It could be infinity. It could be 3. It could be anything. We do not know what 0 divided by 0. It's called indeterminate form. Okay, we don't know what it is, so we can't do it that way. So let's try graphing it. Why don't you grab your calculator and graph y equals sine x over x. Make sure you're in radians and see from the graph what the limit seems to approach as x goes towards 0. I'll pause it here for a second. What do we think the y value is at 0? So I entered in this. Why don't I adjust the window a little bit? I do not need to go all the way up to 10. Why don't I go up to 2 and y minimum of negative 2? How about that? What's the y value as x goes to 0? What's it look like it is? It was a math question, not an arch question. What is the y value as x goes to 0? Keep in mind, I am recording right now. Please answer the question.
1.
1, thank you. Look as I go from the right and from the left, they are both converging to that point right there. It looks like it's continuous. It looks like there's no hole in the graph, but we know that there is a hole in the graph because x equals 0 is not a part of the domain. So 1 is by inspection of the graph. I could even trace it. Hit trace. You can see that my y value is 0.96, 0.99, and we get nothing there. And to the left side of it, 0.96, 0.99, 0.98. So it gets closer and closer. From the graph, we could say that it is 1. So that is one example where using a graph is kind of the way to find the limit there. Because we cannot, well, I'll come back to that. We can't do it any other way except for table. So let's do the table thing. So table is right up here. If I go second table, looks like my table starts at -1 and it's going by 0.1. I don't like that. So we're going to go to table set. You have to be able to do this. So grab your calculator. Table set is right up here. We want to start at 0 because that's where the limit is approaching. X is going to 0. So our table start is at 0. And what's that little triangle mean? What's a triangle looks like this mean? In math or science. Your chemistry teacher would be upset if you did not know what that means. Change, very good. It's called delta, change in. So your calculator, it wants to know on the table, change in the table. Let's make it 0.01. Oops, not 0.0. So my delta table is 0.01, and I'm going to start it at 0. Are you with me? All right, so now we're going to go to table up here, second table, and you can see that just to the left of 0, we're at 0.9996, 9997, 9999. Eventually it gets to 1, and just to the right of 0 at 0.1 or 0.01, we're at 1. So you can conclude that at 0, based off of the table, where it says error, that's probably supposed to be 1. So looking at the graph of it, there's a hole that's really pretty messy. It's a messy speed bump. But it kind of looks like a ghost, too, from Pac-Man, until I put eyes on it. Okay, right there's a hole in the graph, but we know from the table and from the graph that the y value is 1. Okay, so after all of that, we can graph it, or we could use a table to find a limit. All right, another example. The fun continues. what if we have that 10. Okay, so I have limit of x squared minus 4 over x squared minus 3x minus 10. Yeah, that's a 10. X squared minus 4 over x squared minus 3x minus 10. Okay, so we're going to plug in negative 2 here. Please focus. What happens if I plug negative 2 into the top? What do I get? I get 0. What about negative 2 in the bottom? What do we get? Rhymes with hero, starts with Z. Okay, so 0 over 0 doesn't work. Direct substitution does not work, so we have to do different stuff. So let's use our calculators and let's graph this. Make sure you put in parentheses. So this stuff on top divided by this stuff on the bottom. Put it in parentheses and see if you can figure out either from the table or from the graph what the limit is as x approaches negative 2, because we can't just plug it in right now because we get 0 over 0. All right, so I entered it in. I'm going to do zoom standard. Hey, for a piece of candy, what kind of shape is that?
JK.
JK?
No. JK.
Is it like hyperbola?
It's a hyperbola. Well, that was a bad throw. Nice catch. All right, so I can just go calculate value negative 2, and I get nothing. Calculator says nothing's going on. I could go to the table. Oh, I better start my table at negative 2. And I, go to table. And it says error. So based off of this table, what appears to be the limit as x goes to negative 2? What's the y value going to be at negative 2 right here? What's a good estimate? 0.571 would be a good guess, right? So we have an estimate based off table, and table is easier than graph. I'd say that our limit is approximately 0.571, you said. Okay, I would agree with that. Okay, that is not the exact limit, so we're going to do the exact limit and see if our answer is pretty close. If you're given this, think of yourselves as Algebra 2 students again. We actually did this previously this year too also. That's a little redundant. If you're going to look at this in, what's the first thing you would maybe try to do? Very good, you'd factor. You're going to want to simplify this. Can I cross off these x squareds? No. Illegal in the state of Wisconsin. Okay, so we need to factor. Factor the top, x plus 2, x minus 2. Factor the bottom, x minus 5, x plus 2. Now what? I don't use the word cancel, but I'm going to use the word cancel here actually. I cancel those two out and I get x minus 2 over x minus 5. So this boxed in expression up here basically becomes this. They're almost identical. We simplified it. Now remember, we're finding the limit as x approaches negative 2. I can simply plug negative 2 in right now, and I get negative 2 minus 2 over negative 2 minus 5. So I get negative 4 over negative 7, which is 4/7. That is the limit as x approaches negative 2. Ready for this? What is 4 divided by 7? 0.571. Our estimate was pretty dang good. 0.571. So what's the exact answer? No. 4/7. The answer is 4/7. This was an estimate. Okay? On a test or a quiz, if you give me a decimal approximation and you could have done it analytically, you're not going to get that much credit. Okay? Worst case scenario, you grab your calculator, do a table, and you can do it that way all the time. Base it off a graph or a table. But if you can analytically and algebraically manipulate the expression so that you can get an exact answer, that's what you have to do for full credit. Okay? What we just did there is called cancellation method. So number 4 is cancellation method. That's why I used the word cancel. You factor the top, you factor the bottom, you cancel out a common factor, and then you plug it in. Then you directly substitute. So why don't you try one? So find the limit of that as x approaches -3. All right, so we could plug -3 in. I get 9 plus 3, 12 minus 12. So I get 0 over 0, so that doesn't work. I could factor the top, x minus 4, x plus 3. Bottom is x plus 3, x minus 3. Difference of squares. So I have x minus 4 over x minus 3. Now we can plug -3 in. So I get -3 minus 4, -3 minus 6. So I get -7 over -9.
-6.
Well, yeah, I just did some mental math incorrectly. So 7/6. Thanks.
Wait, so what do you put into x?
You plug in whatever x is approaching. So x is approaching -3. Put that in, we get 7/6. How many got 7/6? Raise your hand. Something like that. That's what 7/6 is. Okay, so that's the cancellation method. There's several different other ways of finding the limits. I'm not going to get into it too much, much more today, but I do want to do a couple more examples here. What if you wanted to? What if I wanted to find the limit of absolute value of x over x as x approaches 0? Okay, so we could use our calculator. I'm just going to do a little graph here without a calculator. If I plug in 1 for x, absolute value of 1 over 1 is still 1. Absolute value of 2 over 2, well, that's 2 over 2, which is 1. Absolute value of 3 over, that's just going to be 1. So all of those are going to be 1, no matter what. On the right side, positive x-axis, they're always going to be 1. If I pick -1 for x, absolute value of -1 over -1 gives me 1 over -1, which is -1. -2, absolute value over -2 is going to be -1. So all of those are going to be -1. This is what the graph of absolute value of x over x is. Now, what if I asked you, what is the limit as x approaches 0? That means it has to converge to one point at 0. From the right side, what is it getting closer and closer to? What's the y value? 1. From the left side, what's the y value getting closer and closer to? -1. Do these converge to the same point? No, they don't. So this does not exist. Okay? A limit exists only if it converges to the same point from both the left and the right direction. If I look at, you probably still have, which one did we do on our calculator? This one. Do you still have this in your calculator?
No.
I do. I think I do. Okay, I still have this one in my calculator right here. Now, we manipulated and we got this one that's circled down here. Are these two things the same?
Yes.
Looks like they're the same, right? Everyone agree that they're pretty much the same? There is one thing different from these two right here. What if I ask you, what's the domain of this one right up here? The domain is all real numbers, x not equal to. What are the two numbers that don't work in this squared in one, boxed in one? 5 and negative 2. Very good, because that gives you 0 on the bottom. You can't divide by 0. So that's one of our rules for domain. You can't divide by 0. The other one's square root of a negative number. Okay. What if I ask you for the domain of this one? All real numbers, x not equal to what? Just 5. Negative 2 is a part of this domain. It's not a part of that domain. So if I look at the graph of the boxed in one, which we did, there's actually a hole in the graph right there at negative 2. If I zoomed in, it's still probably not good if there is a hole there. This one right here plugs the hole. It's a continuous shape at that point. That's the only difference. Does the limit of this one exist at negative 2? So I'm going to give you a sketch if I can grab my pen here. Okay, this is what it looks like. Right there, there's a hole in the graph. Does the limit exist right there? It does, because it approaches the same y value from both the left and right side. There's a hole in the graph, but as long as it approaches it, both the left and right side, then the limit does exist. That ordered pair right there is negative 2 comma 4 sevenths. That limit is 4 sevenths. Okay, so if there's a hole in the graph, you can still have the limit. Does the function exist at this point? Is it in the domain? No, it gives you 0 on the bottom. The function does not exist, but the limit does exist. All right, so this is going to take a little bit more time to sink in. I think that's probably enough for today. Questions?